Okay, everybody, welcome back. This is Chuck. It's Malik. And we are continuing the realistic missions. And for the first time, we are jumping into a hard mission. Now, let me put out that this one can be incredibly difficult. Well, no, let me take that back. It can be incredibly time consuming or can be incredibly simple. Now, I am going to show you the way I broke it, I don't know, 4 or 5 years ago. And I'm going to show you how we can break it very, very simply. It's good to do it the long way. It lets you know, even if you don't know programming, we're not going to get into writing your own Perl script to break this thing. I'm going to show you how I did it with Excel. I'm not a Perl programmer. In fact, my weakest part is programming from scratch. I can do it. It just takes me a while. But there's hundreds of different ways to solve this thing. I'm just going to show you the way I did it. So we're going to kind of take this step by step. And again, I'm going to give you the break so you can kind of do it on your own. If you're good at programming, hey, feel free to go around a different way. When I start to point you into a way, you may find an easier way for you. I'm just going to show you the way I did it. So here's the steps here. Toxicode. We have to decrypt a heavily encoded message from a CEO trying to bribe ecological inspectors investigating water pollution issues. Help the environmentalists uncover corporations plotting to profit for the destruction of Mother Nature. So let's jump into the challenge. So here we go from Toxico Watch. And again, we have to send this back to Toxico_watch to complete the mission. So it says, hello esteemed hacker, I hope you've some decent cryptography skills. I have some text I need decrypted. I work for this company called Toxico Industrial Chemicals, which has recently come under fire because of the toxic chemicals we are dumping into the river nearby. Ecological inspectors have reported no problems, but it's widely speculated that they were paid off by Toxico management because of water pollution near the Toxico factory has always been a serious and widely publicized issue. I've done some packet sniffing on my network, and I've recovered this email that was sent from the CEO of the company to Chief Ecological Inspector Samuel Smith. However, it is encrypted and I cannot seem to decode it using any of my basic decryption tools. I've narrowed it down to the algorithm used to encrypt it, but it is beyond my scope. I was hoping you can take a look at it. Please check it out. If you can unscramble it, reply to this message with the original text. It would be much appreciated. And there we go. There is the encrypted text. And again, he says, I believe this document to be encrypted using the Encryption algorithm. Please recover the original text and return it to me. And here's all the stuff. Okay. So, to start out, why don't we just take a look at the Encryption algorithm. Okay. So, again, you want to do a little bit of footprinting, a little bit of recon to kind of understand how this encryption is happening. So you always start out with something simple. Let's just put in A and let's say encrypt it. Okay. Well, let's see what we come back with. Okay, well, what if we do AB? Come on, there we go. Uh-oh, well, those numbers have changed, but we have 6 of them now. Alright, so let's just go back to A again. Encrypt it. Okay. 35, 11, 51. What if we encrypt it again? 4, 31, 62. Okay, this looks like it can become complicated. Well, before we kind of jump the gun here, let's take a look at something. Ugh, the Windows 10 calc is huge. Alright. Alright. Let's see these numbers. We have 4, we have 31, and we have 62. I'm just going to add them together. We end up with 97. Well, if I encrypt it again, and I go back to my calc, we have 7, we have 13, we have 77. Oops, it was still 90, I just squared it. We have 7, we have 13, we have 77. We still have 97. So, don't worry about what the numbers are, just what they add up to. Okay, well, where does that come from? Where did that 97 come from? Okay, so again, 7, 13, 77. Why a 97? Well, if you went through the basic challenges, in fact, I believe it was like challenge number 3, you should know where it came from. It came from our wonderful little ASCII table. Again, remember what number it was? It was 97. It was the A. Well, 97 is a lowercase a. That's where it comes from. Okay. Huh. Okay. Now, they have thrown something in here too. There is an encryption password. And for giggles, let's just put in an A. That's an A. If I encrypt it, I'm going to come up with something else. Well, let's take a look. Let's add those together. I have 92 plus 79 plus 23. I have 194. Well, remember what the lowercase a was? It was 97. Well, what if I subtract 97 from it? I end up with 97. So what we do know is the text by itself, if it's encrypted, it's going to come up with the ASCII of that. If we have an encryption password, it's just going to add the encryption password onto that to come up with that number. So the encryption password just makes it slightly more difficult. But truthfully, you can solve this without even having to worry about that. Okay, so the ASCII table comes in very important. Now, I'm going to show you how I solved it a couple of years ago. What I did was I took, let me go back because that always expires if you kind of wait. In fact, I'll probably have to just drop out of here just to get back to the main page. Here we go. I took all of this, every bit of this information, and copied it and pasted it into Notepad++. And then, even though it was a little painful, I broke it up into 3 groups. So that group, this next group, because remember, each one of these is going to be a letter. So dot number dot number dot number is going to be a letter. Okay? So I put that into Notepad. I eventually, in fact, if I'm not mistaken, I think I still have my file on my desktop. I think I pulled them all out. May not be able to get to it with all this stuff I got going on in the back end. Let me see if I can find it. Yes, there it is. I pulled it out. It was just a text file, so I have it opening up in Notepad. So there it is. Okay. Now, each one of these lines represents a letter. Okay. Now, this is where you can do this 100 times different from what I did. But just to let you know what I did, I took this into Excel and I told it, drop the periods and just put 296 in a column, put 294 in a column, and put 255 in a column. I then added those numbers up. I had to do a little bit of finagling, but I was able to come up with the encryption. Now again, there's 100 different paths you can take. I'm going to show you that Excel file in a couple of minutes. But I want you guys to think about it. Now that you know how this works, how would you go about solving it? Again, there's multiple ways to do it. But how would you go about solving it? So I'm going to give you a minute or so to think about it. There's no right and wrong way to do it. I mean, yeah, there's a way where you can do it in 10 minutes versus a way you can do it in 20 minutes. But we're not worried about time here. What we're worried about is, can you come up with the answer? Now that you know that these numbers come out to be the numbers of the ASCII table, how do you figure it out? Because these numbers look a little bit bigger than what you would think. Okay, so I'll give you a minute to kind of think about that, and then we'll come back and I'll show you my Excel file on how I broke it apart. Okay. Alright. So, I'm uploading a video, by the way. Realistic 5's on its way up. Here's my table. Okay. Now, I don't want to show you this column just yet. Let's just hide this baby for a second. These are the numbers. Okay. It did nothing. I pasted it in from that Word document we just looked at. Now I made me a column here that I just called total, where I added up these three numbers. So those three numbers equals 845. These three numbers equal 859, etc., etc. Well, what I knew I had to do, these numbers are awful large. I mean, 845, you're not going to find that in the ASCII table. You're not going to find any of these in the ASCII table. That's because, remember when we went in and we took a look at the algorithm? When we dropped an A in here and we encrypted it, we came up with this. But when we dropped something inside of here, we came up with a different number. See how big that number is? Well, what if we did something like a Z and encrypted it with a Z? These numbers can actually get too big to fit in the ASCII table. So what I did is I took a look through this whole list. I basically just wrote a formula that said, look through these numbers and find the lowest number. The lowest number was 772. Because what I was looking for was to you knew somewhere in here they were going to have a space. Okay, so I looked for the lowest number to knock it all the way down pretty much to 0, which technically a space is not 0, but knock it all the way back to the beginning of the table, and I'll show you what I mean with that in just a second, because this is where I could have made my life a little bit easier. Okay, so the difference, now this is a little bit different. It's not 83. 845 or 772 from 845 actually equals 73. So if you look at my formula here, I have E3, which is the 845, these numbers, minus 772. But I'm adding 10. Well, where did I get that from? Well, let's go back to the ASCII table, and I think this will become clear. Let's say the letter, it doesn't matter, the letter A. Let's say we would have came up with the letter A. Where I messed up when I first did it, I said, okay, subtract 772. Okay, well, what subtracting 772 was, that's a number that was common to every single letter in that whole encrypted file. So by subtracting 772, no matter where this thing stood, I threw it all the way to the beginning of here. I threw it to 0. Well, let's take a look at these. Null, start of heading, start of text, end of transmission, inquiry, acknowledge, bell, backspace, horizontal tab. No, see, you're not going to find those in a letter. What you will find in a letter is a line feed. That's where they hit the enter key. And look at what number it is. It's 10. This is the lowest number that any letter is ever going to have, unless, well, it could be 9. They could hit the tab key. But on a regular letter, a line feed is going to be your lowest one. It's just where they hit the enter key. So when I subtracted 772, it threw it all the way back to here. So if I was supposed to have, let's say, the capital letter P, I actually ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I actually ended up with an F. And I had to take a look at this ASCII table and go, oh, wait a minute, I went back too far. So I just added 10 to it. Now let me show you what happened when I added 10. What I did was I wrote a special formula. There's a formula there called char, which is character, and said, give me the character for the ASCII code of 83. And I came back with an S. And then I just repeated it all the way down. So what I have is Samuel Smith. Thank you for looking the other way on the increased levels of toxic chemicals in the river running alongside our industrial facilities. You can pick up your payment of $20,000 in the mailbox at the mansion on the corner of 53rd and St. Charles tomorrow between the hours of 3 a.m. and 5 a.m. Thank you, John Sully, Toxico Industrial Chemicals. I then just copied that pasted it inside a notepad, and that's your text. It took a little bit of playing around. It took a little bit of studying that ASCII table. The trick was you ended up with some very large numbers. So you had to take a look at what every number had in common. And the way I did it, I found the smallest number and I pulled that number out. Because they use some sort of encryption. And that encryption is going to happen on every single character, regardless of what the character is. And every one of those numbers were either 772 or higher. So I knew it couldn't be lower than 772. So that was the one I yanked out. Okay. Actually, I really could have yanked out 762 and I would have came back with the right answer. So it just takes a little playing around. So that's the easy way to do it. Now, that's the harder way to do it, but let me show you the easier way to do it now. The easy way to do it now, if I kind of back out of here, is to select everything, copy it, and if you just Google Encryption, there is a web-based tool where you can paste it and tell it to decrypt, and it will immediately come up with the answer. You see the current password value, 762. See, I figured it out at 772. I was 10 off. But I was able to adjust it when I figured out why I was 10 off. Now, all we have to do is take this, copy it, come back here. In fact, I might as well just jump right back to HackThisSite.org. Because again, we have to go into, come on, you can do it. Go back into our name, it's still trying to connect. There we go. Go into here. We want to send a message to TOXICO_watch. And I'll just say encryption, paste it, and send it. And congratulations, you have successfully completed Realistic 6. So ladies and gentlemen, that was a hard one. But play with it. You are going to make a mistake. You are going to be a little off. But that's okay. We all get off a little bit. And again, just to kind of show you what it was, where I was when I first started, I'm going to go ahead and filter these all the way down just to show you the message I was getting when I was like, wait a minute, something's going on here. Before I figured out that I needed to move it ahead forward by 10. This is what I was coming back with, which was total garbage. But again, by studying the ASCII table, I found out that, what this is doing, I'm breaking this all the way back to 0. I didn't want to go back to 0. I just wanted to go back to the enter key, which now started giving me my right characters. Alright, ladies and gents, so that is our first hard mission. So, bonus and congratulations if you guys were on it and could follow along. It could be tricky, but Anyway, what we got coming up next is we're going back to moderate. What is right for America? We got a homophobic hate group is spreading their conservative propaganda of blind obedience and bigoted warmongering. Help tolerance activists take over their website of ignorance and discrimination. So that is the one we got coming up next. So I hope this one helped you out getting through this one. If it did, please, thumbs up, subscribe to the channel, and let me know what you want to see. I'll be glad to post it. But until then, this is Malik, and I'm out.